Hey, what's up guys? In this tutorial we will look at the internal structure of the context package in Golang. As you probably know, a lot of people use the standard context package to build services, and a service would in Go use context throughout. It'd be helpful to think about context in terms of how it works inside. There are several types of context that a Golang developer has to deal with, but first let's pay attention to context creation functions. There are background context, to-do, with cancel, with deadline, with timeout, and with value. The context package in Go defines an interface for managing deadlines, cancellation signals, and other values across API boundaries. This interface can be used to create and propagate context between multiple Go routines. When receiving requests and making calls to service, a context must be created and accepted. The context should be passed through the function chain. If needed, a derived context can be created using functions like with cancel, with deadline, with timeout, or with value. When a context is cancelled, any derived contexts are also cancelled. The package description gives advice: don't store context in struct types, pass the context to each function that needs it. The context should be the first parameter, usually named ctx. Now, for the main point, it seems logical, put the context into the structure, but there are reasons not to do this. The reason number one, pass the context explicitly. If you pass context as context to a function, you can see that it works with this object. If context is hidden in structure, it can be overlooked, which can confuse other developers. The second reason, a context is a temporary object. It's usually created for one request or task and then cancelled. If you keep it in a structure for too long, you can get a memory leak. A Go routine may run even after a query is cancelled, meaning the resources are not freed. Next, changing context at different stages. A new context is often created with additional parameters. If the context is in a structure, it's inconvenient, because you have to change the structure to update the context, which is unnecessary. And last of all, if several Go routines access a structure with the context, it's easy to run into a data race. Storing a context in a structure and giving access to it to different Go routines is a way to get bugs and non-obvious behavior. It's a bit more interesting. It returns the value associated with this context for key, or nil if no value is associated with key. Successive calls to value using the same key return the same result. A key can be of any type that supports equality. Packages should define keys as a non-exported type to avoid collisions. A key identifies a specific value in a context. Packages defining a context key must provide type-safe means of access for values stored using that key. Let's break down the last statement. It's good practice to create a separate type-safe key and access the value in the context by it. And the key should be non-exportable, as this is needed to avoid key conflicts with the other packages, for example. Notes: don't pass values by context. Pass values by parameters, only use context passing when necessary. You can use context passing for a logger or middleware ID, but think it through. With a large nesting context software, documentation deteriorates, and there is a problem of synchronization of teamwork. Empty context is a structure that is never cancelled. It returns nil with all its methods, has no values and no deadline, and implements the context interface. It's used to create a root context that returns context background and context to-do. We can also see the definition of string methods for to-do context and background context, which returns a named representation of to-do and background. This is a context that can be cancelled. Also, when cancelled, all its children are cancelled, which implements the cancellation function. It's created by with cancel. Cancel context is defined as a context that can be cancelled. Because of the tree structure of context, when cancelling, all child contexts must be cancelled synchronously. You just need to go through the children map canceller structure and cancel them one by one. Where is a canceller essentially? It's simply an interface with defined fields. Its implementation are timer context and cancel context. We see the usual context interface definition, where inside just everything is synchronized by mutexes for secure channel access. But more interesting is the following method: propagate cancel organize the cancellation of a child element in the presence of a parent element, set the parent context cancel context. Thus, The propagate cancel method ensures that the cancellation of the parent context is correctly passed to all child contexts, ensuring consistency and simplifying the lifetime management of related operations. As you can see from the source code for creating cancel context, the internal signaling of cancel context depends on the done channel. If you want to cancel this context, you need to block all. See the done. The easiest way is to close this channel or replace it with an already closed channel. In this method, we ensure that the current context and all its child contexts are correctly cancelled, ensuring that all related operations are properly terminated. We can look at the definition of remove child for more clarity. This context is created using with cancel. With cancel returns a copy of the parent with a new done channel. The done channel of a context is closed when the cancellation function is called or when the done channel of the parent context is closed. The cancellation of this context frees resources, so the code must call cancel after operation in this context are complete. Also, cancellation must be called at the level where it was created. Content elsewhere is anti-pattern, as it may leak on closed contexts. The cancel function tells the operation to stop, but doesn't wait. It can be called by several subroutines. After the first call, subsequent calls don't be doing anything. We can pay attention to with cancel. Timer context is built on top of cancel context. The only difference is the addition of a timer and deadline time. With these two configurations, you can automatically cancel the timer at a specific time using the deadline and with timeout methods. With deadline, to look at how our timer context is created, let's look at with deadline. Let's go through the basics. With deadline returns a copy of the parent context with a modified deadline. There must be a set no later than D. The deadline for the parent context is already set before D. With deadline is semantically equivalent to parent. The return context down channel, which is closed when the deadline expires, when the cancel function is called, or when the parent context channel is closed, whichever occurs first. Canceling this context frees up the resources associated with it. So, the code should cancel the call as soon as the operations in this context have completed. We return with deadline calls. Value context. It contains an instance of the context interface, which is a child context, and two fields, key and value. Calling value context with that value performs a recursive search. It's only responsible for researching the context. There is no way to know if a related context contains this key. It has only two methods. Well, the definition of value itself. The method recursively traverses the entire chain of context and returns the value associated with the specified key if such a value is found. If the key is not found in any of the contexts, it returns nil. Also exists after func context. It has only one method and contains an onto context and one synchronization primitive, which is executed only once that after func. The after func function takes a function that will be executed after the context has finished, including timeout cases. If the context has already completed, the function will be immediately. The function is executed in a separate thread. Each call to after func is executed independently of the others. After func returns a stop function. When the stop function is called, the connection between the function and the context is broken. If the context is already in the done state and the function has already been started, or if the function has already been stopped, the stop function returns false. The function terminates if the value is true. The stop function does not expect the function to terminate, so it's recommended to interact explicitly to the function to monitor the state. Without cancelled context contains the standard context interface definition, returns a copy of the parent context that will not be cancelled. When the parent context is cancelled, without cancel. In the same function we create our exemplar. Here are some usage examples. Logging. Suppose you have a service that performs long database queries and logs those queries at the same time. You want the logging process to complete even if the query itself is cancelled. Sometimes you want to cache the results of an operation to speed up subsequent calls, even if the operation is cancelled. You want to keep the results in the cache so they can be used later. without cancel is useful in situations where certain operations need to complete regardless of the state of the parent context. This can be useful for background tasks, logging, caching, and any other task that must be complete even if the underlying operation is cancelled, such as rollback operations. The context doesn't return deadline or error. The value of the done channel is nil. Reading from it will result in program locking. A conclusion. I hope I've helped a bit to understand the inner workings of context. Again, to understand its work better, you should just poke around the source code with your hands and read some unusual cases of using context in practice.